Hello and welcome to my channel. In this video we are going to learn functions and their transformations. Now there are basically three types of transformations. The first one is translation, then comes stretches and reflections. Now each transformation has two types as we can see. So translating graphs has horizontal translation and vertical translation. Now stretching transformations have horizontal stretch and vertical stretch. And reflections are also of two types, that is reflection in the x-axis and reflection about the y-axis. Now once we have understood all these three types of transformations, we are going to learn the correct order of transformations. That is, if we are given a combined transformation of all these three types, then there is a proper order to be followed. That is, we have to see whether stretching needs to be done first, followed by translation or so on. So let us start with the first type of transformation, that is translations. So under the translations, either we can move the given graph to the left or to the right, or upwards or downwards. So here we have considered a function given as y is equal to f of x is equal to x square. So this is the original graph, or this can be called as a parent graph as well. And this is a quadratic function because the highest power of x over here is 2. So this is going to be a parabola. And since the value of x square is positive here, it is going to be a U-shaped parabola. So here we can see that this parabola or this graph meets the x-axis at point 0 and it opens upwards. Now let us focus on the first type of translation, that is horizontal translation. Now under the horizontal translation also we have two types, that is shifting towards the left or shifting towards the right. So if we want to move the function towards the left, the general equation is going to be y is equal to f of x plus a, where a is the number of units you want to shift, that is a is a constant. So remember that for the translation on the horizontal axis, the x within the bracket is going to be changed. Similarly, if you want to shift the function towards the right, the general equation is given as y is equal to f of x minus a. Again you can see this constant a is making only the changes on the x-axis, not on the y-axis. So here the original function was y is equal to x square. So let us apply this translation here. So we have taken a as 1 over here. So y is equal to, so if I want to shift this original function towards the left, and since I have considered a as 1 over here, my graph is going to shift to the left by 1 unit. So here the new equation becomes y is equal to f of x is equal to x plus 1 the whole square. So original function was x square, I just added 1 to it and the new function became x plus 1 the whole square. Now you can see that this 0, 0, this point was touching the x-axis on the parent function. It has shifted by 1 unit towards the left and this point has come on negative 1, 0. So from 0, 0 it has moved down to negative 1, 0. So the x coordinate has changed over here. Similarly, all the points on this graph need to be shifted by 1 unit towards the left. So the entire graph has shifted towards the left. Similarly, if you want to shift this parent function towards the right, we have to write this original equation as y is equal to f of x is equal to x minus 1 the whole square. So the general function is y is equal to f of x minus a. Now since we have considered a as 1 unit, you can see that the 0, 0 coordinate of the parent function has shifted to the right by 1 unit. So the coordinate 0, 0 has now become 1, 0. So all the points on the parent function also needs to shift towards the right by 1 unit. So this is how the horizontal translation works. Now let us consider an exam styled question. So here is the example. Write down the coordinates of the turning point of the curve with equation y is equal to f of x. So the first transformation given is y is equal to f of x plus 2 and the second transformation is y is equal to f of x minus 4. Now here we have been given a function y is equal to f of x and the coordinates of the turning point are given to us, that is 1, 4, where 1 is the x coordinate and 4 is the y coordinate. Now if we look at the first transformation, this is a horizontal translation, that is of the form f of x plus a. So this becomes a horizontal translation towards the left. So this means that we have to shift this turning point towards the left by 2 units. So only the x coordinate is going to change, and when we move this point towards the left by 2 units, the coordinates become -1, 4. That is, if we move 1 by 1 unit towards the left, it becomes 0, and from 0 1 more unit we are going to move, so it becomes -1, whereas y coordinate stays the same. Now let us look at the second transformation. This is again a horizontal translation of the form f of x minus a. So we have to shift the turning point towards the right by 4 units. So again the x coordinate is going to change and it needs to be moved by 4 units or 4 positions. So 1 becomes 2, 3, 4 and 5. So the new coordinates of the turning point now become 5, 4. So you can see again the x coordinate has changed, not the y coordinate. So this is how you are going to recognize the horizontal translations. Now let us move on to the next type, that is vertical translation. So we have again considered the parent function over here, that is y is equal to f of x is equal to x square. Now in vertical translation as well, we have two types. One is shifting upwards and the other one is shifting downwards. So if we want to shift or translate a given function upwards, then the general equation is given as y is equal to f of x plus a. Now a is the number of units you want to shift. So here this is plus a. So if you are writing it as plus a, the function needs to be shifted upwards. And if we want to shift the function downwards, then we are going to write it as negative a. Now you can see that for vertical translations, the a is being added outside the function, unlike the horizontal translations where a was added within the function. That was a was within the bracket. So now let us try to shift the given parent function upwards by 1 unit. So the new equation becomes y is equal to x square. So this was the parent function. Then we are going to add 1 unit to it, that is plus 1. So here we can see that the parent function was touching the x-axis at 0, 0. Now it needs to be shifted upwards by 1 unit. So the same point has been shifted on the y-axis by 1 unit. So the new coordinates are going to be now 0, 1. So here you can see that the x coordinate stays the same, but the y coordinate is going to change. Similarly, if we want to shift this parent function downwards, then we are going to write the function as y is equal to x square. This was the parent function. And then we are going to add -1 to it. So here you can see that the parent function, which was touching the x-axis at 0, 0, has shifted downwards by 1 unit. So the new coordinates are going to be now 0, -1. So the y coordinate has changed, not the x coordinate. Now let us see an exam style question on vertical translation. Write down the coordinates of the turning point of the curve with equation. So this is the same example we had considered for horizontal translation, where the coordinates of turning point were given as 1, 4, and this is the function y is equal to f of x. Now here we have been given the translation as y is equal to f of x plus 3. So this is a vertical translation where we have to shift upwards by 3 units, that is plus 3. So let us look at the coordinates of the turning point. Now it has been given as 1, 4. Now here the y coordinate is going to change, not the x coordinate. So this turning point is going to be shifted upwards by 3 units. So 4 should be added with 3, giving us 7. So the new coordinates of the turning point are going to be 1, 7. Now let us look at the second one. That is y is equal to f of x minus 2. Which means the function y is equal to f of x along with its turning point needs to be shifted downwards by 2 units, that is -2. So again the y coordinate is going to get affected, not the x coordinate. So we have to just subtract this 2 from the y coordinate. So 4 minus 2 gives us 2. So the new coordinates of the turning point now become 1, 2. So in short, to remember the horizontal and vertical translation, you have to follow these general rules. So y is equal to f of x plus a is shifting towards the left. Y is equal to f of x minus a is shifting towards the right. Y is equal to f of x plus a is upward shift. and y is equal to f of x minus a is shifting downwards. Now let us move on to the second type of transformation, that is stretching. Now the second type of transformation is stretching or dilations or compressions. Now here we have considered a cubic function y is equal to f of x. Now this transformation is also of two types, that is horizontal stretch and vertical stretch. So let us first understand what is horizontal stretching. The horizontal stretch is given by the general equation y is equal to f of ax. Now in this stretch, the y coordinate remains the same when we apply this transformation, but all the x coordinates of the graph are going to be multiplied by a scale factor of 1 over a. So this is an important point to be remembered for the horizontal stretch. So for example, if the function is given as y is equal to f of 2x, then all the y coordinates are going to remain same for the given graph, but all the x coordinates are going to get multiplied by 1 over 2. So this gives rise to two conditions. So let us understand those two conditions now. So this is the parent function on which we are going to apply these stretches on this cubic function. So the two important conditions over here are the condition 1 where the value of a is greater than 1 and condition 2 where the value of a is in between 0 and 1. So let us focus on the first condition where the value of a is greater than 1. So a can be 2, 3, 4 or any value which is above 1. Now in this case, when we apply this kind of horizontal stretch, the graph is going to be compressed towards the y-axis. So here we have shown the horizontal stretch to the parent function. Now this red colored graph is the original parent graph, that is f of x. So here we have written y is equal to f of x, and here we have applied the horizontal where the value of a is 2. So all the y coordinates of the parent function will remain same, but all the x coordinate of the parent function are going to get multiplied by 1 over a, that is 1 over 2. So here f of x is the parent function. So let us consider one coordinate on this parent function. So let us take this value. Now this point is just before 4. So we can say it as 3.8, approximately 3.8 on the x-axis, comma 0. Now here the y coordinate is going to remain same, but the x coordinate is going to get divided by 2. So 3.8 divided by 2 gives us 1.9. So we can see that this blue graph is the horizontally transformed function. So this is the point, that is 1.9, comma 0. Similarly, you can take any point on the parent graph and you can check it out. So you can see that this is a compression of the original parent function towards the y-axis. So this graph has compressed towards the y-axis this way, and this has gone inwards this way. So this happens when the value of a is greater than 1. Now let us try to understand the condition where the value of a is in between 0 and 1. Now under this condition, the graph is stretched away from the y-axis. So again we have considered the parent function over here, that is this red colored graph is the original parent function f of x, and let us take the value of a somewhere between 0 and 1. So here we have considered the value of a as 0.5. So here y is equal to f of 0.5x. So a is equal to 0.5 over here. So all the y coordinates of the parent function are not affected, but all the x coordinates of the parent function are going to get multiplied by 1 over a. And since here a is 0.5, we get 1 over 0.5 as 2. So basically all the x coordinates of the parent function are going to get multiplied by 2. So it doubles. So let us consider this point on the parent function which is at 1. So this is going to be 1, 0. So after the horizontal stretch by 0.5, this coordinate is going to be doubled. So we can see that this point has shifted over here. So 1 times 2 gives us 2 and no change in the y coordinate. So we get the coordinate on the new transformed function as 2, 0. Likewise, you can check other coordinates as well. Now let us consider this point again on the parent function, which was 3.8, 0. So after getting multiplied by a scale factor of 2, only the x coordinate is going to change, that is 3.8 times 2, gives us 7.6, which will be over here on the transformed graph, comma 0. No change in the y coordinate. So here you can observe that the parent function is going away from the y-axis this way, and this is also moving away from the y-axis. So this happens when the value of a is in between 0 and 1. Now let us move on to the vertical stretches. Now the general equation for vertical stretch is y is equal to a times f of x. So under vertical stretch, all the x coordinates of the parent graph are going to remain same, but all the y coordinates are going to get multiplied by a factor of a. So for horizontal stretch, all the x coordinates were getting multiplied by a factor of 1 over a. And under vertical stretch, all the y coordinates get multiplied by a factor a. Now under this vertical stretch also we have two conditions. The conditions are same as were in the case of horizontal stretch. That is, the value of a is greater than 1 or it is in between 0 and 1. So let us see the first condition where the value of a is greater than 1. The graph is stretched away from the x-axis. So here we have considered the parent function again, that is y is equal to f of x. And since the vertical stretch is given by the general equation y is equal to a times fx, we have considered the value of a here, that is the scale factor, as 2. So here we get y is equal to 2 times fx, and as we know in the vertical stretch all the x coordinates remain same of the parent graph, but all the y coordinates are going to get multiplied by 2. So here the graph in red represents the parent function f of x, and the graph or the curve in blue represents the transformed graph. So here we can see that all the x coordinates of the parent function remain same, but if we look at the y coordinates, they have got enlarged or they have gone away from the x-axis. So let us consider this point on the parent graph, that is 3. So the coordinate here is 0, 3 as it is on the y-axis. Now the same point has been stretched over here. So 3 has got multiplied by 2, giving us 0, 6. Similarly, we can check out this point as well. This is on the point 2, negative 5. So this has been enlarged as 2, this is going to be negative 10. So negative 5 has been multiplied by 2, giving us negative 10. So when a is greater than 1, the transformed graph is going to be stretched away from the x-axis. Now let us understand what happens when the value of a is in between 0 and 1. Now when the value of a is in between 0 and 1, the graph is compressed towards the x-axis. So here we have considered the parent function y is equal to f of x. So here the red colored graph represents the parent function f of x, and we have considered the value of a in between 0 and 1, that is 0.5. So when y is equal to 0.5 f of x, that is a scale factor of 0.5, we know that the x coordinates of the parent function are not going to get affected, but all the y coordinates of the parent function are going to get multiplied by 0.5, and 0.5 is 1 over 2. So basically all the y coordinates are going to get multiplied by 1 over 2, or they are going to get divided by 2. So let us again consider the point 3 over here on the parent function. So the coordinate is 0, 3. So now the y coordinate is going to get multiplied by 0.5. So 3 times 0.5 or 3 over 2 gives us 1.5. So we get the transformed point over here. So we can see that the original parent graph is being pushed or is being compressed towards the x-axis. So this point has come towards the x-axis now. Now let us consider the point 2, negative 5 as we had considered previously. So here negative 5 is going to get multiplied by 0.5, giving us negative 2.5, which is over here in between negative 2 and negative 3. So this point is also being compressed towards the x-axis. So when a value is in between 0 and 1, under the vertical stretch, the curve is going to be compressed towards the x-axis. Now once we have understood this, let us move on to the third type of transformation, that is reflections. Now under the reflecting graphs, we have two types as well, that is reflection in or across the x-axis or reflection in or across the y-axis. Now here we have considered a parent function y is equal to f of x. So let us try to apply the reflection across the x-axis first. So the general equation is y is equal to negative f of x. That is, we reflect the parent function in the x-axis, which means that all the points which are above the x-axis will be reflected downwards, and all the points which are below the x-axis will be reflected upwards. So the reflection or the mirroring happens in the x-axis. So here the x coordinates will remain same of the parent function, but all the y coordinate signs are going to change. So if the coordinate is of the form x comma y, it changes as x, that is x coordinate stays the same, but the sign of y is going to change, that is positive y becomes negative y, and here if it was negative y, it was going to be positive y. So here we have shown the reflections across the x-axis. So the graph in red is the parent function f of x, and the graph in blue is going to be the transformed or reflected function, that is negative f of x. Now here we have considered the point 2, 1 on the parent graph. So this will be reflected downwards as this point is above the x-axis. So pushing this downwards, it is going to be 2, negative 1. So the x coordinates have remained same, but the sign of the y coordinate has changed. So positive 1 has become negative 1. So the point comes over here. Now let us consider a point which is below the x-axis on the parent function. So we can consider this point. So this is 0, negative 1, which is below the x-axis. So it will be reflected upwards. So the point is now going to be over here, and the coordinate is going to be 0, 1. So negative 1 has now become positive 1. So this is how the reflection happens in the x-axis or across the x-axis. Now let us look at the reflection across the y-axis. So for the reflection in or across the y-axis, the general equation is y is equal to f of negative x. That is, we reflect the parent function in the y-axis. So the y coordinate remains the same in this reflection, but the x coordinate signs are going to change. So if the coordinate on the parent function is of the form x, y, after the reflection in the y-axis, the coordinates are going to be negative x, y. So here if it was negative x, y, it was going to change as positive x, y. So now we have considered the parent function f of x over here, and we have considered the point on the parent function, that is 2, 1. Now this is going to get reflected across the y-axis, that is, this point is going to go towards the left. So the points which are on the right are going to move to the left, and the points which are on the left are going to move towards the right. So now 2, 1 is going to get reflected as negative 2, 1. So the point is going to be over here. So you can see the points on the parent function as well. Over here, they have all got reflected towards the right. And here all the points have got reflected towards the left. So this is what the reflection across or in the y-axis is going to look like. So in short, if it is going to be the reflection in or across the x-axis, the general equation is going to be y is equal to negative f of x, and the reflection is going to happen upside down. That is, all the points below the x-axis are going to go up, and all the points which are above the x-axis are going to go down. And in the reflections across the y-axis, the general equation is going to be y is equal to f of negative x. That is, all the points which are on the left side are going to move towards the right, and all the points which are on the right side of the y-axis are going to move towards the left. Now once we have understood the three types of transformations, let us understand the order of transformations. So under the order of transformations, we have to follow certain sequences, with the first step being start with innermost parentheses in a given function, look for possible horizontal shift or translation if the power of x is 1. This could be a vertical shift if the power of x is not 1. So let us try to understand this point by using two examples. The first step is we have to start with the innermost parentheses. So this is kind of order of operations where you use BODMAS or PEMDAS. So first step is starting with parentheses. So the function f of x is given as x minus 2 the whole square plus 4, and the function g of x is given as 3 times x square minus 2 plus 4. So before we begin with any transformation, we have to first start with the parentheses. and in f of x the parentheses is x minus 2, and in g of x inside the parentheses we have x square minus 2. So in the first point given, the power of x in the innermost parentheses is 1. This is x minus 2 within the parentheses where the highest power of x is 1. Then we have to go for horizontal translation. That is, we are going to translate this function towards the right by 2 units. And over here for g of x, within the parentheses, the highest power of x is not 1, it is 2. So this is not going to be a horizontal translation, this is going to be a vertical shift. So we have to vertically shift the function x square downwards by 2 units. So this is one of the most important points you have to remember. Look for the parentheses and check for the power of x within the parentheses. If the power of x is 1, then go for horizontal shift, and if the power of x is not 1, then you have to go for vertical shift. Now step number 2 is going to be any stretches or compressions or dilations. Now over here for f of x, we do not have any stretches, that is, we do not have any scale factor. But in case of g of x, we have a scale factor of 3. So this is going to be the second step for g of x. First is vertical shift and then comes the stretch. Then the third step in order of transformation is any reflections if there are. So here there is no reflection in f of x, there is no reflection in g of x. For example, if f of x was given as minus x minus 2 the whole square plus 4, then the third step over here was going to be reflection. Then finally comes the vertical translations. So in f of x plus 4 is going to be a vertical translation, that is, this function goes upwards by 4 units. And here also this plus 4 represents the vertical translation. So the function g of x moves upward by 4 units. So step number 1 is looking at the parentheses and finding out the power of x and applying the horizontal or vertical translation. Step number 2 is applying any stretches or compressions or dilations given. Step number 3 is performing any reflections given. And finally we have to go for vertical translations. So let us understand these steps by using some examples now. So the first example is f of x is equal to x minus 4 the whole square minus 5. So let us first write down the parent function to which the transformations need to be made. So here the parent function f of x is going to be x square. As we can see, we have applied the translations to the parent function. So since this is f of x equal to x square, this is going to be a quadratic graph, that is a u-shaped parabola. So this is going to represent the parent function. Now let us start with the sequences. The step number 1 being checking out the power of x within the parentheses. So within the parentheses we have the function x minus 4 and the power of x is 1 over here. So here we have written power of x within the parentheses is 1. So we have to apply the horizontal translation, that is, the parent function is going to be horizontally shifted towards the right by 4 units. So here we have shifted the original parent graph, which was in red, by 4 units towards the right. So you can take one point over here, that is 0, 0, and you can see that we have shifted this point by 4 units, that is 1, 2, 3 and 4. So the point has appeared over here on the new transformed graph. So all the points on the graph will be transformed by 4 units towards the right. Now the next step was stretch or compressions or dilations, and we can see that there is no scale factor for the given function and there are no reflections as well. So here comes the -5, which is the vertical translation. So we have to shift this blue graph downwards by 5 units. So here we have written. Next comes the vertical translation, that is downwards by 5 units. So here we can see that this blue graph has shifted downwards. So let us consider this point again, which is 4, 0. So if we are shifting it downwards by 5 units, so it goes to -1, -2, -3, -4 and -5. So the point comes over here. Similarly, all the points on this blue graph are going to be translated downwards by 5 units. So this graph in green represents the complete transformed function. Now let us move on to the second example. Now the second example is f of x is equal to minus x plus 2 the whole square plus 3. So the first step is identifying the parent function. So we can see that the parent function is f of x is equal to x square, to which the reflection, horizontal translation and vertical translation has been applied. So once we have got the parent function, we have shown it over here. So it is again going to be a parabola, that is a U-shaped quadratic function. Now the order of transformation, step number 1 is we have to check for the power of x within the bracket, which is 1 in this case. And since the power is 1, we are going to apply the horizontal translation, that is the parent function is going to be shifted towards the left by 2 units. So here we have shown the translation. So the red graph is the parent function. So let us consider the point 0, 0. So this has to be shifted towards the left by 2 units. So the point comes over here. So similarly, all the points on the parent function will be shifted towards the left by 2 units. Now once we have got this, the step number 2 in the sequences was stretching. Now we can see that there is no scale factor for the given function. So moving on to the step number 3, we have reflection over here. That is x plus 2 the whole square is getting reflected in the x-axis. So now this blue graph is going to get reflected in the x-axis. So here we get the graph as reflection across the x-axis. So you can see that all the points above the x-axis have been reflected in the x-axis, giving us a mirror image. Now once we have got this, the final step is vertical translation. So here we can see that the vertical translation is given as +3. So now after the reflection is done, we have to shift this reflected graph up by 3 units. And for that, let us consider this point, that is -2, 0. So if we are pushing this point upwards by 3 units, so here we have 1, 2 and 3. So the turning point will be coming over here. So here we can see that now the translated graph is over here. So similarly, the entire points on this graph are going to be translated upwards by 3 units. So this is the final image of the transformed graph. Now let us move on to the last example. F of x is equal to 0.5 times x cube plus 1 plus 2. So here the parent function is a cubic graph. So f of x is equal to x to the power of 3. So the cubic graph looks this way. So we have drawn the parent function over here. Now applying the order of transformation, step number 1 is to check the power of x within the parentheses. Now the power of x over here is 3, not 1. So this becomes a vertical translation. So we have to translate this original parent function upwards by 1 unit. So here you can see that we have shifted this parent function, which is in red, upwards by 1 unit. So all the points on this graph will be shifted upwards. Now once we have done this, the second step was stretching, and here we can see that there is a vertical stretch of 0.5. So the cubic function is going to be multiplied by 0.5. So the x coordinates are not going to get affected, but all the y coordinates of this function are going to get multiplied by 0.5. So here we have shown the vertical stretch by 0.5. So this blue graph was the one which had got translated upwards by 1 unit. So we can consider this point to understand it better. So this is 0, 1, and if we are going to multiply 1 by 0.5 for a vertical stretch, we should get 0.5. So the point has got compressed and it has moved towards the x-axis. So this is compression. Similarly, if you take a point over here, which is 1, 2, the x coordinate is not going to get affected, but the y coordinate is going to get multiplied by 0.5. So 2 times 0.5 gives us 1. So we can see that the point has got compressed and the point has appeared over here on the green graph. So 1, 2 has now become 1, 1. Now once we have applied the vertical stretch, next was reflections. Now here in the given function, we cannot see any reflections being given, but there is vertical translation. So we have to move this function, vertically stretched one, upwards by 2 units. So here we have done the last step. So let us consider this point, which was at 0.5. So if we are moving it by 2 units upwards, so it should be at 2.5. That is 0.5 plus 2 gives us 2.5. So here we can see that the point has appeared over here. Similarly, all the points on this green curve are going to be shifted upwards by 2 units, giving us this completely transformed graph. So this is the completely transformed function. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.